So the goal by the end of this video is that you understand what a binary and a ternary compound is, and then you know how to name both types of compounds. So make sure you know how to name compounds by the end of this video is our goal. We'll start by talking about what is a binary compound. A binary compound is composed of two different elements. So examples here are aluminum chloride and sodium chloride. Notice this has sodium, chlorine, two elements. So we'd say this is a binary compound. Aluminum, chlorine, two elements. So it is a binary compound. You may notice that there's a 3 here. So you might say, well, there's 1 aluminum and 3 chlorines. So that's more than 2 elements. But no, don't think of it like that. Think of it, how many different types of elements? There's aluminum and there's chlorine. Doesn't matter if that there's a bunch of chlorines. There's only 2 different elements. You can only name 2 elements in this compound. So that's what you're looking for. How many elements can you name in the compound? The answer is 2. It's binary. This one, sodium, chlorine, 2. It's also binary. Now here's how you name them. You take the first element. The first element's typically, it's usually always a metal. The second element is usually a non-metal. And for the first element, you just name it. So notice when I name this one, sodium, it's just sodium. And then the second element, you take the root of it and give it an IDE ending, so chloride. Hints for finding the roots. Most of them are on your yellow sheet. I showed you those when we did covalent naming. If it's a halogen, if it ends in INE, you just replace the N with a D. So the INE, chlorine, turns into chloride. So an example, NaCl. Na plus is sodium ion, it's the metal. The Cl minus is the chloride ion, it's a non-metal. So what you do is you write sodium chloride. You name the metal just as it is. You look it up on the periodic table. No need to change it. And then you name the root of the nonmetal and give it an IDE ending. Notice there are no prefixes in this, so do not add prefixes to an ionic compound. The other thing, when you start the worksheet, if you get ahead on the worksheet, naming compounds, I'm going to have you leave a space between the 2 words because we're eventually potentially going to add more information in there. We don't add prefixes, but there is an extra piece we add in the middle of the 2 words. So just leave a little extra space to add some Roman numerals in there later. That'll be in the next video. I just want to warn you now in case you try to get ahead. Leave some space so you don't crowd yourself out later. So some examples. We've got Mg and O. So I name the metal, which is just magnesium. Magnesium. And then oxygen turns into oxide. And that's it. I'm done. No prefixes, nothing else. And again, notice I left a little space there just in case I need to add something later. For the next one, try the next 2 on your own. Pause the video and come back. Excuse me. So for this one, aluminum. Al is aluminum. Let me make sure I spell it right. And then nitrogen turns into nitride. And on these, we're not going to actually go back and add anything. These are not ones you need to. But on the worksheet, you don't know yet which ones you need to add something to, so leave a little space in there. The last one, Ca is calcium. And then iodine. Doesn't matter that there's 2 of them. No prefix needed. I just write calcium iodide. That's it. No prefixes. Super easy. Okay, a ternary compound. Well, you probably figured out by now that if binary is a compound that has 2 elements, ternary has 3 or more elements. And it's going to contain a polyatomic ion. And so you might be like, oh my gosh, how do I do this? It's actually super easy. If you have a ternary compound, that means there's going to be a polyatomic. So it's typically a metal and a polyatomic. The only case where it's not is if you have ammonium in there. And we'll look at that, I believe, in one of the examples. So example is FeSO4 or NH4Cl. So in this case, I could name iron, sulfur, oxygen. That's 3 different elements, so this is a ternary compound. In this compound, I can name nitrogen, hydrogen, and chlorine. That is 3 different elements, so that is also a ternary compound. So in your worksheet, you'll be asked to label ternary and binary. So T for ternary, B for binary. So just count the elements up, 3 or more, ternary. If there's 2, it's binary. Now, like I said, it's typically a metal. So in this case, iron, and then the polyatomic is sulfate. Unless you have ammonium, because ammonium is a positively charged polyatomic, it's the only one we deal with that's positive. It will come first, and then here you got a nonmetal chlorine. Okay, so here's how you name them. It's usually a metal for the positive ion. It's usually a positive polyatomic for the negative ion. Like I said here, it's typically this setup, but sometimes you might have ammonium that would be the exception to the usually here, the usually part of that phrase. So what you do is you name the metal, then you name the polyatomic, and that's it. You don't change any of the names. You don't add an IDE ending or anything like that if it's a polyatomic at the end. And the exception is NH4 plus. It's treated as a metal. Let me quick check the next slide. Okay, yep, I put a bonus in there. So I will cover this exception in the next slide. So I'll show you an example of that. So the examples here. You should have your yellow sheet out so that you can learn the name of these, or so that you can write down the names of the polyatomics if you don't have them memorized yet. So in this case, I named the metal. Li is lithium. The NO3 is, if you look up the polyatomic, it is nitrate. So we got lithium nitrate for the first one. So nothing special here. Name this, you're done. And you look this one up on the periodic table, you look this one up on your yellow sheet. So for the number 2, you've got Ca, which is calcium. And then you look up this one. A lot of times, well, let me quick do this, then I'll go over the mistake I commonly find. OH is hydroxide. Okay, so this is just calcium hydroxide. Doesn't matter that there's 2 of them or anything like that. No prefix is needed. I just name this and I name this calcium hydroxide. I'm going to point this out right now. These 2 get mistaken a lot. They are not the same thing. Hydroxide is OH with a minus charge. Hydride is hydrogen with a minus charge. So hydroxide and hydride are not the same thing. One's H, one is OH. The next one. This can be hard to figure out where to split it. We actually did this as an example for our oxidation numbers, but you'd split it right here. You look up, okay, NH4 is ammonium. This actually has 2 polyatomics, which is possible. Ammonium, and then you look up this one. Its name is acetate. So this is just ammonium acetate. The last example I'm going to give you is this one. This one's a little tricky because it kind of follows the binary rules a little bit. You start by naming the ammonium. So you put ammonium down. Because this is a non-metal, at the end you still have to give it the IDE ending. So chloride. So normally for all the other ternary ones, you'd name the metal, the polyatomic. It's that easy. No IDE endings needed. So like lithium nitrate. No need to change either of the names from what's on the periodic table or yellow sheet. But if you do have ammonium at the beginning and then a nonmetal, the nonmetal still needs the IDE ending if it is at the end. So that's where we'll end this video. If you have your worksheet, what you should be doing is labeling them B or T, and you can start practicing naming them. And then again, leave a gap between the 2 words. Because the next video I'll show you how to add Roman numerals if it needs Roman numerals. Not all of them do, but some of them do. And at this point, it's better to just leave a space in all of them because you don't know which ones you're going to need to go back and add that to. So I will leave you here.